Chemical engineering is all about choices. It's up to the engineer to know how choices they make can affect the end product. Engineers want processes that are quick, efficient, and environmentally friendly, while still ensuring the best end product. To create the best products and the best processes, chemical engineers make choices about factors such as equipment, temperature, agitation, raw materials, time, pressure, and much more. Today we're going to see how we can all be chemical engineers in the kitchen and see how we can change some of these factors to affect the cookies that we make. At the end of the day, who doesn't love a perfect chocolate chip cookie? There's actually a lot of chemistry behind baking that is rarely considered. There are a few different chemical processes that occur when baking a cookie, including the decomposition or breakdown of baking soda, the reaction of caramelization, and the interaction between butter, flour, and eggs. The first reaction happening in the oven is the breakdown of baking soda, also known as sodium bicarbonate. The chemical formula of sodium bicarbonate is NaHCO3. When heat is added to sodium bicarbonate, it breaks down into sodium carbonate, water, and carbon dioxide. This allows the cookies to rise because water vapor and carbon dioxide will be pushing up through the dough in the oven. The second reaction that is occurring is through a process called caramelization, where heat is being added to sugar, also known as sucrose, to break it down into glucose and fructose. From glucose and fructose, it can be further broken down into simpler molecules to create the sweet, savory flavors we love in a cookie. The third and final interaction that is occurring is the interaction between the butter, eggs, and flour. The ratio of these three ingredients will determine the spread or the diameter of the cookie. Butter breaks down the structural integrity of the dough in the oven as it is melting, while the flour and eggs try to uphold the structural integrity of the cookie. The balance of these three ingredients gives the cookies their round shape. Now let's talk about the equipment involved in baking. You can approach the baking process as you would any other chemical engineering process, where the first thing you are going to have to decide on is the right equipment to use. Using the right equipment is important in any engineering process to achieve your desired product efficiently. This can be applied with the baking process too. During baking, you want the oven to remain at a high temperature, around 350 degrees Fahrenheit, to allow the cookies to bake properly. An insulator is commonly used to keep the heat contained within a system. Ovens are manufactured with good insulators, so a minimal amount of heat is lost from the oven. Insulators can be commonly seen in engineering processes to keep the heat contained within a system. Accurate measurements are a key factor in any successful process. Common equipment that is often used to keep track of these measurements are pressure gauges, timers, thermometers, or conductivity probes. In the case of baking, a thermometer will be used to keep track of the temperature, and a timer will be used to keep track of the time. Safety is always an important factor that needs to be taken seriously. In engineering, we call safety equipment personal protective equipment, or PPE. In baking, the PPE would be the oven mitts. Once the correct equipment is chosen and safety precautions are taken, you need to decide what to put in your cookies. Raw materials heavily influence the end product of a chemical process. You can't expect to add red and blue pigments to produce a green product. In the same way, you can't expect to add a lot of salt to a cookie and expect it to taste good. We have to be chemical engineers in the kitchen and choose the right portions of raw materials to get the most delicious cookies. When comparing sets of ingredients to test the influence of raw materials on cookies, the right ratios are important. In the case of baking powder versus baking soda or sodium bicarbonate is very basic. This property gives a slight bitter taste to the overall cookie. Baking powder, on the other hand, contains both an acid and base, which gives the cookie a neutral taste. Butter is also important to consider. Melted butter and softened butter yield significantly different results, with different tasting cookies. Melted butter makes chewier cookies due to the fat being broken down from heating the butter. On the other hand, the softened butter creates a more crisp cookie and has a more consistent shape due to the slow breakdown of fats. Brown sugar and white sugar also create slightly different results in a cookie. Brown sugar is granulated sugar that contains molasses. The molasses retains moisture and gives the cookie a more soft and chewy texture. The darker the brown sugar, the more the flavor of the natural molasses dominates. In the other case, white sugar is well refined and does not contain any natural molasses. Baking a cookie with white sugar results in more caramelization, which gives a more crisp and crunchy cookie. You can alter the taste and texture of a cookie by choosing specific raw ingredients and ratios to produce your perfect cookie. Once you've chosen your set of raw materials, you can begin to mix these ingredients together to create your cookie dough. Mixing is a common process that chemical engineers encounter in industry. Mixing may seem like a basic step, but in reality, it's a critical step in the process that requires lots of care and attention. When working in industry, chemical engineers need to ensure that the ingredients are mixed fully together, creating a mixture that is homogeneous or uniform throughout, to ensure the mixture is distributed evenly. Proper mixing also creates more interaction between molecules to make product that would not necessarily occur if it were not mixed. Order of addition is a critical step for mixing raw materials together. In industry, we always want to make sure that we're adding raw materials in a correct and safe order. Adding in the wrong order could result in the wrong end product or even an unwanted side reaction that could be dangerous. In the same way, we have to be careful with mixing our cookies. An important part of this is when we mix our wet and dry ingredients separately. Once we add liquid to our flour, we activate the gluten protein, and if we overmix after this activation, we will end up with tough, chewy cookies. Now that you have the perfect dough to work with, let's see how you can use time and temperature to bake your cookies to perfection. Temperature and timing of a process are very important in chemical engineering because these factors affect the products of a reaction. Chemical engineers must run their reactions at precise temperatures and times so that their reactions are given enough time to properly react. The temperature and timing are both important factors in making the perfect cookie, whether you like a thin and crispy or a thick and chewy cookie. The average time a cookie bakes at is 10 to 12 minutes. So if you bake a cookie at the recommended temperature of 350 degrees Fahrenheit for this time range, you will end up with a well-baked cookie. If you don't leave the cookie in the oven long enough, you will still have a raw cookie. If you leave the cookie in too long, you will end up with a burnt cookie. Again, the typical temperature a cookie bakes at is 350 degrees Fahrenheit. If the temperature were to increase by 100 degrees to 450 degrees Fahrenheit, the cookie will appear burnt on the outside but raw in the middle. The right temperature is important when baking to achieve an evenly baked cookie. This balancing act of time versus temperature means that you have to carefully consider both these factors when baking your cookies. It's up to an engineer to make choices about many factors of production, and these factors account for the product you end up with. Chemical engineers are responsible for making even more products than you're aware of. The choices that chemical engineers are making affect the batteries in your cell phones, the plastics that are in your sneakers, the medicines that are helping people live longer, the gasoline that powers your car, and much, much more. In the same way that chemical engineers can alter the products around our lives, we can be chemical engineers in the kitchen and make sure that we end up with the perfect batch of cookies every time.